Okay, we are here for video lab number 8 today. We're meeting today's team.
Davey.
Frankie.
Takia.
Big Phil.
Big Phil, with an F. Phil with an F. Okay, as opposed to empty. Phil, empty. Okay. All right, who can tell us what's the lab all about today? What are we trying to do today? Yes, Wilson.
Density metal.
Yes, we want to find the density of a metal. The last time we were here, and actually not the last time we were here, but the last time we did a density lab, we were trying to find out the density of a what? Of a wood block. And today we're trying to figure out the density of a metal. It doesn't matter what we're trying to figure out the density of. We have to know two things about the object to figure out its density. Okay, who has the metal? Phil, hold that metal up. Okay, now, what's one of the things that we have to know about that piece of metal to know its density?
Volume.
The volume. And what's the other thing we have to know about it?
Weight.
The weight. Okay, so if we know the weight, we know the volume, we can figure out the density. Hold it up one more time to the class. Can you tell me, class, what metal is that he's holding up to you? Take a look at it. Yes?
Brass.
Brass. How'd you know that?
Because, I guess.
Well, no good.
The color.
The color told you it was brass. So the physical property of color was enabling you to figure that thing out. Okay, now, hold it up one more time. If this was a math class, what geometric shape is the object that he's showing you right now?
Cylinder.
A cylinder. Now, there is a mathematical formula for figuring out the volume of a cylinder. What might it be?
Pi R2H.
I squared H. That's very good. Very good there. So what's pi? Say it loud.
3.14.
And that is a cherry pie or an apple pie? Neither. Okay. What's R in this formula? Say it loud.
Radius.
Radius. And what's H in this formula?
Height.
Height. Okay, now, it's not a math class, so we're going to try to figure out the volume in a different way. What do we call the way that we're going to try to figure out the volume? There's a special name for it.
H2O displacement.
Say it loud.
H2O displacement.
Water displacement. And in order to do that, we have a piece of equipment over here, hold that up, that we haven't used before. And who can tell us? Would you like to buy a vowel? Who can tell us what the name of that equipment is? You got the overflow part.
Overflow flask.
Overflow flask. Who can say that 3 times quickly? It's a tongue twister.
Overflow flask, overflow flask, overflow flask.
Okay. Not bad, Phil, with an F. Okay, so Phil, would you describe for us what has to go on now for us to get the volume of that cylinder?
Well, I have to fill this up with water and then let it pour out. And then when I put this metal in, make the water come out into here.
Okay, and what happens when you put the metal in? What happens to the
Oh,
water?
the water comes up.
Okay, and how much water will come out?
I don't know.
Yes, you do.
It depends on the...
No? It depends on what?
Oh, it depends on 6.0.
No. How much water will come out? Tell us.
Depends on the metal. The weight.
Specifically, how much water is going to come out? Why are we doing this? Say it loud. The volume of the metal will come out. Okay? So, Phil, since you know what to do,
Yes.
there's a sink up there. Do it.
Okay. I'm going to do it.
He's going to do it. He's going for it.
Oh, my sleeves, just a little.
Okay, we're getting tired now. That makes no sense, of course, what I just said, but nobody questioned it. This is what Phil would look like if it was leaking out of him. So the water that is coming out right now is the volume of that piece of metal. Now that thing that he's catching it in, what is it called, the thing that he just caught the water in?
A beaker.
No, it's not called a beaker. A graduated cylinder, okay? And what unit is it measuring in? What metric unit? Milliliters. And Phil, if you would look at the meniscus, what's the meniscus, Phil?
6.0.
Yeah, but what's the meniscus mean?
Oh, the little dip thing.
Yes, so Phil has come up with 6.0, and Davey, where it says milliliters, if you could put in 6.0. Okay? No, actually don't, because it says liters. We want to do this in a unit called grams per liter, but he's got milliliters. Mathematically, what do we have to do to milliliters to create liters?
Divide.
By
1,000.
1,000. Why are we using the number 1,000? What's the relationship between the two?
1,000 milliliters in a liter.
Very good. Okay, so now you said 6.0, right?
Yes.
Now you're going to have to visualize this number because it's the PMS system that you're going to do now. It's 1,000 on the outside. It's 6.0 on the inside. Who can give me the answer? 1,000 into 6.0.
0.006.
Very good. So if you would put down for liters, 0.006. So now we have half of what we have to do. The other half is the weight. That's where Frankie comes in. If you could pass, oh, you got to get the thing back out of there. Phil, do the magic for us. The magic was you're supposed to take the thing out right away. Okay, it's all right. Phil, that wasn't part of the magic. Now, why does Phil have to dry off the metal? Yes.
Water adds weight.
Yes. So we want to get the weight just of the metal.
Gotta get my little flask thingy.
Okay, now give it to Frankie. And what unit is the scale going to measure? Grams. So Frankie, if you would weigh it up for us.
It's
Not yet, Frankie. We're not done checking our children here.
I'm not stupid. Because he's got his hand on that little button. That's how I know.
Guys, I don't.
Okay, Frankie, what you got?
54.0.
54.0, if you could write that down next to the weight, 54.0. Okay. We got the weight, we got the volume. Mathematically, how do we get the density?
Volume weight divided by volume?
Yes, weight divided by volume. Here's where you come into Kia. You have the two numbers that they just gave you. Plug it in and see what you come up with.
9,000.
Okay, 9,000, and the unit is grams per liter. So if we had a piece of metal made out of brass that was the size of a liter, it would weigh 9,000 grams. Anybody have a liter with them?
I carry my rum in it, but I seem to have drunk it all.
Okay. Hold that up. So that's a liter. So if the piece of metal made out of brass was that big, it would weigh 9,000 grams. Sounds like a big number, 9,000 grams. Okay, let's change it to something that's smaller. What unit can we change grams into to make 9,000 a smaller number?
Kilograms.
Kilograms. And how many grams make up a kilogram? 1,000. So therefore, how many kilograms would 9,000 grams equal?
9.
9. Now, you're not used to really at this point talking about the metric system and what kilograms really mean to you because you're used to doing weight in what unit? Pounds. So now, what would 9 kilograms equal as a pound figure?
19.8.
Very good, Wilson, because Wilson knows that every kilogram is worth how many pounds?
2.2.
And by multiplying the two numbers out, he comes up with 19.8. Okay, very good. So a piece of brass the size of your liter, where's your liter?
Oh, sorry.
Okay, something that big would weigh just under 20 pounds. That's pretty heavy because it's so dense. Now, my next question to you, why did the answers for the densities come out to be different for the different groups?
They were all different metals.
Different metals. And even groups that had the same metal came out different because of the V word.
Variable.
Variables. And what could be some of the variables that happened in this lab that had to do with what Phil did for you up there?
Maybe when they put in the flask, they dropped and water splashed out.
Okay, what other variables?
Too much pumping.
Too much pumping. What other variables?
Too light pumping.
Too light pumping. What other variables?
Too hard pumping.
Too hard pumping. You guys pumping a lot out here. You guys pump iron a lot? We know what you pump, but never mind. What other variables? Any other variables? Lots of variables, right? All things that could control the results of this particular lab. Do you remember which metal came out to be the densest?
Brass.
Brass, the one that you used. And which metal came out to be the least dense? Okay, here's my next question for you. How many of you have ever played baseball or softball before? Do you notice when you play this, if you're not in the major leagues, there's two kinds of bats that you can use? What are the two kinds of bats?
Aluminum and wooden.
And wooden. Okay, now, notice they use a bat made out of aluminum, right? Why don't they use a bat made out of brass?
Aluminum's lighter.
Right, and what would happen to you if you try to use a brass bat to do something? Well, there'd be a lot of momentum from the bat, but also it would take you a harder time and a longer time to come in contact with the ball. It'd be harder to swing the bat because of its density, okay? So if somebody's running after you with a bunch of metal bats to hit you over the head, you want to be hit with what type of metal? Aluminum. So just ask for the choice. Okay, did a really nice job. This ends video lab number